Picture yourself standing on a serene, sunlit beach. The rhythmic whisper of the waves meets your ears. The horizon stretches endlessly before you, its vastness both humbling and inspiring. Beneath these gentle, shimmering waters lies a universe that has been evolving, thriving, and transforming for more than 500 million years. The ocean is more than just a backdrop to our planet's story. It is the original stage upon which life's drama has unfolded. Every grain of sand, every coral branch, each darting fish and drifting plankton is a living thread in a tapestry that has endured since before the very first forests took root on land. But now, in our own fleeting moment on this planet, this story, so long defined by resilience and renewal, faces an unprecedented turning point. For nearly 540 million years, the oceans have been the engine room of life. They have supported a teeming, ever-expanding web of creatures. This grand narrative is written not in words, but in stone. In a groundbreaking study, scientists from Stanford University set out to answer a fundamental question: how has the sheer mass of marine life, the biomass, changed over Earth's vast history? Their quest led them to analyze more than 7,700 limestone samples, painstakingly collected from every continent. Each sample, carefully sliced and examined under a microscope, reveals tiny shells and fossilized remains. A time capsule, capturing moments from ages long past. Imagine opening a diary where every page is millions of years old. At the dawn of the Cambrian period, over 500 million years ago, fewer than 1 in 10 rock samples contained visible shell material. It was a newly awakening world, just beginning to discover the power of complexity. As the Ordovician period arrived, propelled by the Cambrian explosion, a surge of evolutionary creativity, the portion of shell material in rocks soared, rising above 1 in 5 and maintaining this high level for much of the next 230 million years. This was not just an explosion of animal life, but the birth of new ecological relationships: predation, symbiosis, and competition, all unfolding beneath the surface. Yet, Earth's history is marked by both triumphs and catastrophes. The fossil record speaks of 5 mass extinctions, moments when life was nearly erased. The most devastating, known as the Permian-Triassic extinction, or the Great Dying, struck about 250 million years ago. Shell material and rocks plummeted to just 3%, a silent testament to the scale of loss. Ocean ecosystems were shattered, and it would take millions of years for them to recover. But recover they did. Through the Mesozoic era, when reptiles ruled the seas, and into our own Cenozoic era, the age of mammals, marine life rebounded and diversified spectacularly. In recent geological times, the volume of shell remains in rocks sometimes exceeded 2 in 5, thanks to the flourishing of corals, mollusks, and other organisms that build shells and skeletons from calcium carbonate. As Dr. Pulkit Singh, lead author of the Stanford study, observed, "The overall pattern we captured is a gradual increase. This persistent upward trend is a testament to life's resilience, a principle as old as the oceans themselves. After each extinction, life returned, often in new forms and ever greater abundance. The oceans seem to be on an unbreakable winning streak, building richer, more intricate communities with every era. This pattern has been remarkably consistent, regardless of continent, latitude, or ocean depth, as confirmed by the rigorous cross-checking of the Stanford research team." But our chapter in this ancient story is different. For the first time, the ancient momentum of the seas, a 500 million-year legacy of recovery and renewal, faces a threat not from cosmic impacts or volcanic infernos, but from the daily actions of a single species. Humanity, in a matter of centuries, has become a geological force, shaping the fate of the entire biosphere. Our fingerprints are everywhere, from the chemistry of the atmosphere to the composition of the deep sea. The evidence is stark. Since the middle of the 20th century, global phytoplankton biomass, the microscopic plants at the base of the marine food web, has declined by roughly 2 in 5. This is primarily due to warming oceans and increasing acidification, direct results of our relentless carbon emissions. Phytoplankton are not just food for fish. They generate over half of the oxygen we breathe, and are responsible for drawing down immense amounts of carbon dioxide from the atmosphere. Their decline is not a distant statistic. It is a blow to the very systems that make our world habitable. And this is only the beginning. The Great Barrier Reef, one of the most breathtaking natural wonders on Earth, has lost more than half its coral cover in just 3 decades. Mass bleaching events, triggered by marine heat waves, have transformed vibrant reefs into skeletal remnants. In the frigid waters of the Southern Ocean, krill populations, a keystone resource for whales, seals, and penguins, have collapsed by close to 4/5 since the 1970s. Even the Patagonian shelf, a biological hotspot teeming with life, has suffered a 1 in 5 reduction in zooplankton biomass, driven by shifting ocean currents and rising temperatures. The threats are multiplying. Plastic pollution, once thought to be confined to coastal waters, now pervades even the most remote ocean trenches. By the middle of this century, scientists project that plastic waste could reduce marine biomass by as much as 1 in 7. Microplastics have been discovered everywhere, from the snows of the Arctic to the guts of deep-sea fish. These tiny shards are ingested by marine life, disrupting food webs and even making their way onto our dinner plates, with unknown consequences for human health. Overfishing has also left deep scars. According to Dr. Daniel Pauly, a leading fisheries scientist, industrial-scale fishing has decimated populations of top predators such as sharks and tuna. The removal of these apex species often triggers cascading effects throughout the food web, destabilizing entire ecosystems. Dr. Boris Worm warns, the ongoing decline in marine biomass threatens ocean ecosystem services and human well-being. Climate change magnifies these pressures. The Arctic tundra, once a powerful carbon sink, has now become a net source of carbon due to escalating wildfires and the thawing of permafrost. These changes release more greenhouse gases, fueling the cycle of warming and further destabilizing marine environments. Ocean acidification, meanwhile, is eroding the very foundations of marine life, dissolving the shells of mollusks and corals before they can grow to maturity. Deep-sea mining, a looming technological threat, could disrupt the recovery of benthic communities for decades, jeopardizing some of the planet's most fragile and unexplored ecosystems. The cumulative effect is alarming. Dr. Ayanna Elizabeth Johnson, a leading marine biologist, sounds the alarm. Urgent action is needed to reduce carbon emissions and protect marine habitats to safeguard ocean biomass. The Worldwide Fund for Nature stresses the critical importance of protecting key habitats, coral reefs, seagrass beds, mangrove forests, to maintain both the mass and the diversity of marine life. What are the consequences if we fail to act? If current trends continue, we could witness a catastrophic collapse of marine biomass in the coming decades. Fish stocks, according to some projections, could fall by between 1/5 and nearly 1/3 by the middle of this century. This would trigger ripple effects throughout global food systems, since over 3 billion people rely on seafood as their main source of protein. Coastal communities, especially in developing nations, would be the hardest hit, facing both economic hardship and a rising tide of food insecurity. The decline in marine biomass is not just an ecological crisis. It is a humanitarian emergency. Ocean ecosystems provide services worth trillions of dollars every year, from absorbing carbon and protecting against storms, to supporting livelihoods for millions of families. Coral reefs alone are the foundation for a quarter of all marine species, and their loss would be a body blow not just to nature, but to tourism, fisheries, and coastal resilience. As Dr. Jane Lubchenco observes, marine protected areas are effective tools for conserving and restoring marine biomass, but they require effective management and enforcement. The good news: history shows that nature can rebound if given the chance. Ambitious conservation efforts can yield dramatic results. The creation of marine protected areas has led to ecosystem recovery, increased fish stocks, and even boosted local economies. In Cabo Pulmo, Mexico, a well-managed no-take reserve saw fish biomass increase by more than 400% in just a decade. Similar success stories have unfolded in the Philippines, the Mediterranean, and the Pacific Islands. These examples prove that with the right policies and community engagement, the ocean's resilience can be unlocked. But the path forward is not easy. Effective conservation requires not only setting aside protected areas, but also enforcing regulations, supporting local communities, and adapting to the shifting realities of a changing ocean. In some places, traditional knowledge and modern science are coming together to design innovative solutions. For instance, using seasonal fishing closures based on the life cycles of key species, or restoring mangroves to buffer coastlines against storms and provide nursery grounds for young fish. If nations take decisive action, reducing carbon emissions, enforcing stricter fishing regulations, and protecting critical habitats, it is possible not only to halt the decline, but even to reverse it. Some models suggest that with comprehensive, coordinated action, global fish stocks could increase by between 1/10 and 1/7 by the year 2040. This would not only help restore marine ecosystems, but also bolster food security and economic resilience for communities around the world. New technologies offer additional hope. Advances in sustainable aquaculture, the farming of fish, shellfish, and seaweed, could relieve pressure on wild stocks while producing nutritious food. Some of the most promising aquaculture projects now mimic natural food webs, reducing waste and disease. Satellite monitoring, drones, and artificial intelligence are transforming how we track illegal fishing in real time, allowing enforcement agencies to intervene more effectively. There are even bold ideas, such as ocean geoengineering, enhancing the ocean's carbon uptake, for instance by seeding iron to promote phytoplankton growth, or cultivating vast kelp forests to absorb carbon and provide habitat. While these interventions are potentially powerful, they carry risks. Ecosystems are complex, and unintended consequences can ripple far and wide. The key, experts insist, is to proceed with humility, guided by science, and to avoid seeing technology as a silver bullet for deeper social and ecological problems. But solutions are not only the domain of policymakers and scientists. Each of us has a role to play. Start with your plate. Be mindful of the seafood you consume. Look for sustainably sourced options, certified by organizations like the Marine Stewardship Council or the Aquaculture Stewardship Council. Reducing single-use plastics in your life, choosing reusable bags, bottles, and packaging may seem small, but collectively, these actions can help stem the tide of pollution entering our oceans. Support conservation organizations through donations, volunteering, or by amplifying their messages. Even small contributions can add up to significant impact when millions join in. Education is a powerful catalyst for change. Talk to your friends, family, and community about what you have learned. The more people understand what is at stake, the greater the pressure for political and economic transformation. Use your voice literally. Write to your elected representatives. Call for stronger marine protections, more ambitious climate action, and sustainable fisheries management. Demand that leaders prioritize the health of our oceans, not just for wildlife, but for people everywhere. Even a single message can matter, especially when multiplied by millions who care. Let us also remember the vital, often overlooked, role the oceans play in stabilizing our climate. The world's oceans store more than 9/10 of the planet's excess heat and absorb about 1/4 of all human-made carbon dioxide emissions. This remarkable buffering capacity slows the pace of global warming and shields us from even more extreme climate impacts. But this buffer is not infinite. If marine biomass continues to decline, the ocean's power to regulate climate could falter, unleashing even greater chaos across the globe. Looking ahead, humanity stands at a crossroads. One path leads to continued degradation, with cascading losses in biodiversity, food security, and climate stability. The other offers the chance to restore balance, drawing on our knowledge, technology, and collective will to nurture the blue heart of our planet back to health. Experts envision several possible futures. In the bleakest scenario, if humanity fails to act, marine biomass could decline by as much as 1/5 to 1/3 by the year 2050. Entire ecosystems, coral reefs, kelp forests, upwelling zones could cross critical tipping points, becoming mere shadows of their former selves. The collapse of fish stocks and the loss of keystone species like krill would reverberate far beyond the oceans, affecting weather patterns, coastal economies, and even the air we breathe. Such a decline would not only threaten marine life, but also unravel the social and economic fabric of coastal communities around the world. The World Bank estimates that ocean-based industries provide livelihoods for more than 300 million people. Imagine the disruption if these industries were to collapse. A more hopeful scenario is within reach, but only if decisive, coordinated action is taken now. Ambitious conservation, investment in innovation, and robust international cooperation could stabilize marine biomass and even restore it to healthier levels. Some projections suggest that with serious global efforts, fish stocks could recover by 1/10 to 1/7 within 2 decades. This would sustain vital ecosystem services and open up new opportunities for economic development, especially in regions that depend most directly on the sea. There is even the possibility of a transformative breakthrough, a blue renaissance, driven by technological advances. Imagine aquaculture systems that closely mimic natural food webs, producing healthy seafood with minimal environmental impact. Picture fleets of autonomous drones monitoring ocean health, detecting illegal fishing, and alerting us to emerging threats before they spiral out of control. Visualize restored coral reefs and expansive mangrove forests, buffering coastlines from storms, supporting both wildlife and people. In Norway, for example, cutting-edge aquaculture facilities already produce significant amounts of salmon, using innovative recirculating systems that minimize waste. In Indonesia and the Philippines, community-led mangrove restoration projects are helping to rebuild crucial coastal habitats, reducing erosion and fostering biodiversity. Of course, history warns us that even well-meant interventions can have unexpected consequences. The challenge is to pair ambition with caution, ensuring our solutions work with nature, not against it. For instance, the introduction of non-native species for aquaculture has sometimes led to ecological imbalances. The lesson: we must strive for adaptive management, learning from both successes and failures, and always prioritizing the health of natural systems. Ultimately, the fate of the oceans, and by extension, our own future, rests in our hands. We are the first generation with the knowledge, technology, and global connectivity to fully grasp the scale of the challenge. We may also be the last with the chance to avert irreversible damage. As Dr. Sylvia Earle, the renowned oceanographer, once said, "No water, no life. No blue, no green." So what will it be? Will we be remembered as the generation that broke the blue planet, or the one that saved it? The answer depends on the choices we make today, tomorrow, and in the years to come. The science is clear. Our actions over the next decade will shape the oceans for centuries. We have the tools, the ideas, and the power to change course. But we must act urgently, and we must act together. If you care about the future of our oceans, let your voice be heard. Share this video with friends, family, and anyone who relies on the sea, which, in truth, is all of us. Leave your thoughts in the comments below. Support organizations working to restore marine life. And most importantly, join the movement for change. The tides are turning. The question is, will we rise to meet them? The fate of the oceans is not yet sealed. Together, we can ensure that the story of life beneath the waves continues, not as a tale of loss, but as a testament to what humanity can achieve